Hi, I hope you are doing well. Today I will show you how to test the group difference using multi-level vector autoregression. Uh, so we have two groups. Group A, also called the control group, as Group B, also the named treatment. So we can compare between them to define if there is a difference, signal, or just noise. So most of these models are used in psychological and some field of sociology. Uh, so, for example, psychological research often asks, is the dynamic network of Group A control different from Group B treatment? As the visual observation is the subjective, we can't define or we can't be sure that there is a difference only by using the network. So we need to use other computational methods. So the model is like this: state subject, and we have time, time E, time, or it can be year, month, or other. And S is belong to the subject specific. Uh, it means the group, is it group A or group B? And the set of variables captured by the lag coefficient. You see that the dependent variable, which is yt, is lagged to capture the temporal or the path dependence. And innovation or results. So the purpose is to test the difference in the distribution of these parameters across group. I can show you the data. This is the data that will be used in the example. So this is the group. I think we have 5 groups. Uh, and also I should show you the code in R. I already executed the model because it takes time to execute and to show the results. I only took the row from 1 to 100 because the data is too large. You see that the data has uh, more than 2,000 rows. It will take time to execute all the data. So I only took 100 rows. So this is the model. So the purpose or the parametric test, it use compute t-test for on parameters. This is the distribution of the group A and group 2 or the treatment. The test is to compare between the mean of the first group with the mean of the second group. Also, we should take in consideration primary assumption that the distribution of the group follow a Gaussian distribution. This is the parametric test that we use in other packages or other models. Also, In our case, when using the multi-level VAR, we assume normality. This assumption is mostly violated in many data, example of psychological data. So we cannot test the random effect variance in the data. So the non-parametric permutation test that we will be used in the multi-level VAR. As I told you, it takes time. It's heavy computationally. It takes time. This is why I took only 100 row, but robust to non-normal data. As I told you, traditional or conventional test model assume a Gaussian distribution of the data. So to use the parametric test or the t-test, the data should have or should follow a Gaussian distribution. But if we use non-parametric permutation, this assumption is not required. In the data, we are using, or this is the example of the data. First subject is the group, is the data identifier. In our case, we have from 1 to 100, and there is the time identifier in our data. This is the and the group identifier must be binary. This is only a capture of the code, the function that is used in the mlVAR. I will leave this presentation in the description. So this is a summary of the package. So the primary focus or the purpose of the model is to analyze time series data across multiple subjects. These models are particularly useful when individual measurement points are insufficient to estimate separate VAR. As you see, we have large data, so it's not possible to use the traditional VAR. So this multi-level VAR is robust for this kind of data. This is the multi approach. This is the variable that capture the multi-level. So we have 6 level data. In this data, we have this survey platform. This survey was captured using 3 types of platform. So this is our multi-level group identifier. So the key model structure, 3 distinct network. There is the temporal network, contemporaneous network, between subject network. In the code, this is where you capture the network. This is where you capture the network. You specify the type. Is it temporal or contemporaneous? Or there is another case. It's in the package. Let me check package. and the function is plot. So I will go to plot. This is there is temporal, contemporaneous, and between subjects. So I will leave also this PDF to show you code. Showing our areas across different important package information, two-step approximation. In the testing group difference, while researchers often compare these models between group patients. In our case, we have group A and group B. Patient B versus controls. Formal information has this. So also, I will leave this word. It has many important information. So I will execute the code now. The data called dataset CS. This is the data, and the spreadsheet called data color text. Data color text. So I only I have three treatments. I will focus on treatment one. So I selected only the variable that has this T1 since the data has me. This is the row. I'm now focusing on T1. Any variable that has T1, I capture it in the code. It also has T3. This is the variable that relates to treatment 1, and this is for treatment 2, and this is for treatment 3. As I told you, the data is too large, so I did select only row from 1 to 100. And this is the dimension of the, we have 100 row and 38 column. So this is to estimate the correlated random effects. This is the ID variable, the identifier VAR variable. I selected the contemporaneous correlated, temporal correlated as LM estimator. So it takes time to estimate all the, to do the computation. Let me check the summary. So this is the group. We have the seven group. Check. This is the Bayesian criterion, information criterion, and this is applied functions. Information criterion. Applied information criterion. So the model, best model, is the one that minimize this Bayesian. If we compare, we find that this model is the most significant, and this is the temporal effect. Log one contemporaneous effects are the between subjects. Second step is to plot the temporal type of the network. So this is the network. These are the models, are the variables orthogonal temporal relationship. This is the green line. It means it is positively significant, and the dashed green line, it means positively non-significant. Red is not significant or negative. This is correlated with itself, its autocorrelation. I'm now using contemporaneous. It's take time to understand green significant, so dashed insignificant. Red, it's negatively insignificant. Another estimation is using the orthogonal with the 200 iteration. You can do comparison between this model and this model by changing the parameter and doing the interpretation using different. Second is to plot the temporal. And the contemporaneous. The purpose of the model is just to show you how to use the package. I will share this data and the code, so you can adapt you can adapt the code with your data. I also will leave this the package guide. It contains some important information. Also, this paper of the developer of the package has some important information, equation, and the package is flexible to use change color and any other related parameter. So I will what else? I also will leave this presentation of the package. Package is called the mlVAR. So thank you, and I hope I get some like and maybe try if that's so. Thank you for your attention.